Hi audiences, my name is Pundchisa P. I am graduated from Chemical Engineering at KMUTT University Technology of Thunbury. This clip will present biodegradable plastics and improve the miscibility of polymer blends using amphiphilic diblock copolymers. The objectives of this clip are proceeds effects of climate change from undegradable plastics, which is one of the source of climate change, and to support biodegradable plastic. Moreover, this clip will tell you the process of biodegradable plastics. Introduction. Climate change is one of important issues that come from various activities of humans, such as warming oceans, the falling of the glacier, and sea level rise, which also affected living things. So, the level of issues is increased and expanded the effect around the world. Furthermore, the problems of plastic waste management were brought the trend of bioplastics. What is bioplastics? Bioplastics are plastic that derive from renewable biomass sources, such as plant-based material that come from vegetable fats, oils, corn, starch, wood, chips, etc. There are three types of bioplastics that will be explained in this presentation, which consists of PLA, PBS, and PBAT. Each type has weak capability, and this presentation will proceed the way to improve PLA capability for biodegradable polymers. Let's start with PLA. PLA or polylactic acid was synthesized from lactic acid. This type of plastic is the most successful of biodegradable polymers. Main properties of PLA are brittleness, which is a huge problem to form PLA in other applications. PLA also has low crystallization rate and low gas transition temperature. The second type of bioplastics is polybutylene succinate, or PBS. PBS is more flexibility than PLA, so that PBS can blend with other polymer easily. The shape of PBS is sphere, and PBS has high impact of strength. That means PBS is hard to degradable than PLA. This type of bioplastics can degrade by anaerobic decomposition, which we'll explain further. The last type of bioplastics in this presentation is PBAT, or polybutylene adipate coterephthalate. The properties of PBAT are strong and toughness. PBAT also can blend with other kind of polymer easier than PLA. The molecule size of PBAT also bigger than PLA too. Followed by improving the miscibility of polymer blends by using amphiphilic diblock copolymers. Nowadays, the environment becomes worse than the past. Plastics is the one reason of these problems. So, humans try to find the plastics that can degradable in environment to replace polyester, which is hard to degradable. In this presentation, we'll emphasize on PLA. Polymer blending is the one method that used to replace these advantages, which becomes our objectives. Diblock copolymer reactive blending. Diblock copolymer inserted between polymer A and polymer B, which are polymer based, for reducing interfacial tensions. From the diagram shows that a part of diblock co compatibility with polymer A and C part of die block can compatibility with polymer B. The next part of presentation is methodology. These are using materials consist of various types of polymer, lactic acid, MPEG, and stannous octatate. Traditional methods to synthesis of the block copolymers and preparations of polymer blends. MPEG PLA D block synthesized by ring opening polymerizations of La mixed with MPEG lactic acid stannous octatate in ratio 0.3% weight of acid. Purified and dried solution under vacuum. Then the products is the block copolymer, which shows as follows. The next steps is synthesize polymer blends. And the last steps is melt blending PLA and the block copolymers with base polymer. Let's move to results and discussions of improvement the miscibility of polymer blends with and without the block copolymers. When it comes to pristine blends between PLA and PBAT, distinct gaps walls occur with poor interfacial adhesions. From the pictures, the round particles of the PBAT faces distributed into the PLA matrix. There are two interfacial layers, which means PLA and PBAT immiscibility lead to poor interfacial adhesions and strong interfacial tensions. Move to with the block copolymers produce MPEG PLA products. The block copolymer reduce dispersed phase size and the gap between the PLA and PBAT. So it increased compatibility of polymer blends, lead to strong interfacial adhesion. Properties of the block copolymers in PLA and PBAT blends. In pristine blends between PLA and PBAT, brittle ductile occurs with smooth fracture surface. The unstable structure at the gap lead to brittle fracture like stiff PLA. The PBAT component in the matrix was not effective in toughening PLA. With the block copolymer, make interfacial layers stable and improve the ductility of the blends. The types of fracture of polymer blend is moderate ductile. Continue with microstructure of the blends of moderate ductile. A small amount of compatibilizers was affected. For example, improve the interfacial adhesions between polymer blends with copolymers. From the pictures, polymer blends of PLA and PBAT with copolymer names ME45 L36. The fibers begin to indicate on the fractured surface. Also, in other kinds of copolymer, fibers also appear on the fractured surfaces of the blends with diblock copolymer. Move to theme of the block copolymers in polymer blends. PBAT phase and the block copolymers were dispersed in the matrix in the form of nanomicelles. The nanomicelles act as an effective degrading agent to strengthen the crystal growth of polymer blends between PLA PBAT blends which was affected crystallization rate. As you can see, PLA and PBAT polymer blends with the block copolymers Me45L9 is difficult to find the larger particles of PBAT. Rheological properties of MPEG PLAT block copolymers effectively in polymer blends. From the line graph, as you can see, the highest breaking point is the blue line. By increasing PLA stress and elongation, also Me45L18 copolymers is the best result of improved ductility of polymer blends. From the green color of the bar graph, increased crystallinity may imply an increased elongation in the blend and indicating the better compatibilization. In this research, the elongation at break of the blend with Me45L18 the block copolymers was as high as 296%. Crystallinity rate, which can observe from the table, is 26.8%, which is the highest one. Conclusion. MPEG PLA block copolymer act as compatibilizer was improved the miscibility of PLA-based polymer blends by reduce the brittleness. Also provide the stable interfacial structure which can reduce the interfacial tensions. Let's start with the simple definitions of biodegradable. Biodegradable is an item that can break down into natural materials in the environment without causing any harms by using microorganisms. As I mentioned in the previous chapter about biodegradable plastics process. Start with PLA degradable. PLA can degrade in temperature more than 40 degrees Celsius. That's near temperature gases of PLA, which equals 55 to 62 degrees Celsius. The next step is fragmentations. These steps, fragmentations, break down plastics into small pieces. The temperature and moisture of landfills are the main factors that were affected. After that, the degradation process begins called hydrolysis process. When it comes to PBS degradable, PBS can degrade by anaerobic decomposition, which we'll explain further. PBS degrade in temperature more than 55 degrees Celsius with low rate of degradations. The next process is aerobic decompositions, which can decompose PBS at 67 degrees Celsius. Then hydrolysis process was occur. This kind of biodegradable plastics was not tolerated in high temperature and can absorb water. So the last steps of PBS biodegradable is degradation by microorganisms. Okay, it comes to the last types of biodegradable plastics, which is PBAT. PBAT was biodegraded from two kinds of decomposition that are anaerobic and aerobic decompositions. Start with anaerobic decomposition. Is degraded without oxygen by using soil from landfills waste and biosludge to bury biodegradable plastics. But this kind of decomposition was degraded slowly because it has only little oxygen can pass through, which can observe from the weight of plastics that was loosed. Next is aerobic decomposition, which degraded with oxygen by composting landfills and by solarizations. Composting is the fastest degradation because of high oxygen, which can measure from volume of carbon dioxide. In the way that bury in a landfills, plastics was decayed at surface and produce holes. Finally, the plastic will crack. The internal of PBS can decay by solarization, which was made bioplastics brittle. Another important thing in biodegradable is microorganism. Microorganism in biodegradable is a living thing that can decompose bioplastics. In this presentation, there are three types of bioplastics, which are PLA, PBS, and PBAT. Therefore, bacteria and fungus can decompose all of these bioplastics. There are two types of species, which are bacteria and fungus, that involve in bioplastic degradable. First, start with bacteria. These two types of bacteria cannot be cultivated and grow at high temperature. Also, these two kinds of bacteria can live in both aerobic and anaerobic conditions. When it comes to fungus, this species of fungus named Candida tropicals cannot survive without oxygen, so it can be found in both PLA, PBS, and PBAT. How to use plastic sustainable. To use plastic sustainable, in this presentation would like to talk about 3R, which consists of reduce, reuse, and recycle. Let's start with reduce. Reduce means minimize unnecessary resources what you are using. In this presentation, focus on energy and products from fossil fuel, such as manufactured from plastics, and all of this can start from ourselves. For example, there is innovation that can replace plastic straw to reduce single-use plastics. This innovation is named seaweed straw, which can be degraded in 60 days, but plastic straw is used around 1,000 years to decompose. Due to long-term cycle, almost plastics products are made from PP, or polypropylene, and PET, polyethylene terephthalate, which were used thousands of years to degrade. The second R is reuse. The main part of reuse is worthwhile use the product as long as you can instead of buying new. Reuse can start easily from your simple things, which we'll explain further. You can see that reuse can start with simple things such as bring your cup or take away box. This can boost people to reuse things in other way, to encourage customers not to produce more single use of plastics. You can see that reuse can start with simple things such as bring your cup or take away box. This can boost people to reuse things in other way, to encourage customers not to produce more single use of plastics. I believe that most of you have heard this word recycle and see this sign before. Recycle depends on material that was used to produce product. For example, glass, paper, aluminum, metal, and e-waste. There are 5 main kinds of recycled waste, which are metal, paper, glass, plastics, and e-waste. In Thailand, there are a few places to receive e-waste, and a few people do not know how it's dangerous. To avoid harmful effects and sustainable development, each community should create small stations to give people knowledge and receive their own batteries exchange. Thank you everyone that come to listen to my clip. Always remember that everybody in this world can make this world better. Just start from yourself, your two hands, to raise this world and raise your life.